Everybody, this is Mr. Beckstrom, and I had a question about an exercise from section 5.1 in the homework. This is number 3. It says approximate the area of the region bounded by the graph of f of x shown below and the x-axis by dividing the interval 1 to 5 into n equals 4 subintervals. Use a left and right Riemann sum to obtain two different approximations. So draw the approximating rectangle. So this is using Riemann sums, and this is kind of how we get into the idea of the integral, which we're going to be doing really next section here. So the Riemann sums is we're just trying to calculate the area under a graph, and Riemann sums is basically just making rectangles and then finding the area of those rectangles and then adding them up. So your answer is usually either going to be over or under what the actual area is, and let's take a look at it from here. So the first one says do a left Riemann sum, and what that means is we're going from 1 to 5, so from here to here, and we want to use 4 subintervals. So if we use the formula for the delta x here is just that's going to be the right endpoint, which is 5, minus the left endpoint, which is 1, divided by n, which is 4, and so that's just going to be 4 over 4, which is equal to 1. So they set it up so we have just a 1 width rectangle, and then we're going to find the lengths. So it's going to be from 1 to 2, from 2 to 3, from 3 to 4, and from 4 to 5. Sometimes it's not going to be 1, sometimes it's going to be 2, or sometimes it's going to be some kind of fraction, but it's nice when they make it either a 1 or a 2 here. So now what we're doing is we're trying to get a area for this region of the graph. So under this curve here, above the x-axis here, and between these two x values 1 and 5. Alright, so using the left Riemann sum, what we're going to do is we're going to use so for each one of these rectangles here, from like 1 to 2, and then from 2 to 3, 3 to 4, and 4 to 5, the height of this rectangle is going to be the left-hand side of that rectangle. So for this first one here, we're going to use the left side of this to go up to the top of where the graph is, or where the curve is, and then we go over and back down. Now from 2 to 3, we're going to use the left side of that rectangle, so just go up until you hit the graph, and then come back down. Then from 3 to 4, same thing. We're going to go up on the left side until we hit it, and then come back down. And then from 4 to 5, we'll do the same thing, and come back down. Now, notice that the area is probably not going to be the same as the area of these rectangles combined, because we're missing some area here, but we're have some extra area over there, so it should be somewhat close, but it's just usually not going to be exact. But now to find the area using the left Riemann sum, we just count up the number of squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So that's going to be an area of 26 using the left Riemann sum. Alright, now let's do the right Riemann sum, and let me kind of erase what they have here, and we're doing the same thing. So we're still going from 1 to 5, although this time we're using the right side of that rectangle for our height. So for this first one, we're going to use the right, so go all the way up until you hit the curve, come over, and then come back down. Same thing here, go all the way up until you hit the curve, go back down. Remember, we're just using the right side of these rectangles as the height. Go back down, and then finally, oops, that a little bit nicer. Go up here. And so here is our estimate using the right Riemann sum for the area under the curve between 1 and 5. So counting up, 1, 2, 3, 4, 5, 6, 7. Got one there. So 7 times 4 is 28. So the right Riemann sum is going to equal to 28, an area of 28. And then eventually, we're actually going to take the integral, which uses the antiderivative, in order to find the exact area. And we're going to end up finding that it's going to be somewhere between the left Riemann sum and the right Riemann sum. All right. If you guys have any questions, please let me know. And I hope everybody has a great rest of your week. Thanks.